Hello, this is Gus, and today we're going to talk about a really tiny, small, organic LED displays that cost around $4. Those have been very common lately, and you can find them on eBay and on like AliExpress, Alibaba, on different websites that directly ship from China. And these displays are 128 by 64 pixels. They're one color, but some of them come white or blue. And some of these displays actually have the top 20–30% of the display yellow and the bottom is blue. So they have two colors. It's not multi-color display. It just happened that those LEDs on the top are different color. Over here we can see the top and the bottom of those displays. And they are very simple. They come on a breakout board. And the price, you can find them between $3 and $6, including the breakout board. I've seen them as low as $250 in volume, if I remember correctly. But still, around $4, it's a pretty beautiful, nice display, and I'll show you the display running in a second here. And it's I2C, so it's really easy to wire. I2C bus just has two signals, the clock and the data. So we have clock, data, and then we have the other two would be power and ground. And these are actually nicely labeled on the top. So when you plug it in, you can see which is what. By just looking at the PCB. Now, how do we wire this and use it? If you happen to use one of our products, the FEZ boards, those are the Frickin' Easy or Fast and Easy boards. These are also labeled very well. Everything is right on the PCB. You don't need to pull any schematics. Looking at this one, for example, we need the two I2C pins. If I'm looking at this board, which is the FEZ Lemur, the I2C pins are labeled right here, I2C. There's SDA and SCL, the data and the clock. And if you're using another board, they are labeled as well. What I happen to use in my demo is the FEZ Cobra III. And this is the FEZ Cobra III. It's actually already connected to the display and it's running. Let me show you. So we have the FEZ Cobra with the display running. It's just a little demo that I did. It's a counter and then they have the two circles going back and forth. And the way when I looked for the pins on the Cobra has a lot more IOs, so there's no room to put every feature of every pin on the front. But we have them listed on the back. So if you look at the back, looking down here, I can see all the other functions. I see I2C, SCL, SCL, and SDA on pins D2 and D3. That's what I did. Added the two wires to D2 and D3. Connected those to the display, the appropriate pins, the SDA and SCL. Connected the power and ground. I started looking for code because I need to code it. Now the challenge was it's like anything else you get from China typically. It's cheap, but then there's no documentation, there's no example source code, there's no support. So I had to do some search, and I found out that the controller is called SSD1306. That's the controller that is inside the display. So I need to find code for the SSD1306. Did some more searching and I found a really nice driver made by Adafruit. It's on GitHub, downloaded the code, and running on C#. I had to do some modification, C or C++, I think it's C to C#. It's not much different, so the changes are easy. So I changed all the code to run on C#. Run it on the board, the display still did not work and I couldn't figure out why. And I double checked the back of the display for the I2C address. Every I2C device has they're slaves. The main board is the master, and every other device connected on the bus is a slave. So every slave has its own unique address on the bus. And looking at the back of the board, I see that it's a 0x78. And that's what I used for an address, but I couldn't get the board to work. And then I realized that the 78 is actually the entire 8 bits. With the I2C bus has a 7-bit address, not 8 bits. The first bit is either read or write, so it's the 7 higher bits. So all I had to do was take that 7/8 and shift it down once. So you can take that and just add shift operator right 1, or you can just put 3C instead. That would be 7/8 shifted down 1 would be 3C. So I changed that to 3C, and the display started working as expected. Another beautiful thing that's worth mentioning here is that I'm using the built-in graphics that is built into the system. So when I draw a text or a circle or any other shapes on the screen, I didn't have to write any code to draw a circle. There is a bitmap class that's built in, and I'm using that to draw text, to draw circles or shapes. And then I would take that bitmap, and we provide a converter class that converts the bitmap to raw bits, if you will. And one of the options was converting that to a single bit. And this is what this is. Every pixel is a single bit, since we don't have level of brightness and we don't have colors. So every individual pixel is a bit. I use the converter to convert the bitmap to a single bit array, 128 by 64 bits, not bytes. 128 times 64 divided by 8, that's basically 1 kilobyte. So using the bitmap, the converter will take that bitmap, it will spit out a 1 kilobyte array that I would send to the display, and then it will end up being rendered on the screen. Pretty simple, straightforward. The address was the only thing that took me a bit to realize that it's not the wrong address, it's the right address, but it's a 7-bit versus 8-bit representation. Beside that, stepping through code, thanks to the system that allows me to step through code, and I'm using USB cable from Visual Studio, and I can see what's happening. So this helped me quite a bit. But next time you're looking for a display, I highly recommend you grab one of these. $4, including shipping. You would have a beautiful display that is really easy to wire. And if you need the code or if you need help, just let us know and we'll be more than happy to help you out. Thank you very much. I hope you found this useful.